All right, so next up we're talking about how to use direction fields. Using the direction field. So last video we created this direction field, but I told you that we would use this tool to learn something about the solution to a differential equation. Right now this doesn't seem to tell you that, and so we need to know how to use this graph. So given a direction field, which I've abbreviated DF when it's too long to write out, what we're going to do is we're going to start at any point some x0, y0, and that's going to be the initial condition of an initial value problem. So when we learned about initial value problems, we're given some y of x0 equal to y0, the place where the differential equation solution should start. And so when we look at the direction field, we want to start at that point, x0, y0. Then, once we start from that point that belongs to the initial value problem, and the arrows show us the slope that gives the differential equation, we're just going to follow the arrows. And that's going to give us an approximation of the solution to the ODE from that initial condition. So it's a solution to the initial value problem. So for example, let's say I had the initial value problem, dy dx is equal to 0.2xy. That's the equation we were working with before. And I wanted to start at y of negative 10 is equal to 10. In this case, my x0 is negative 10 and my y0 is 10. So I want to start at the point negative 10, 10. So let's go ahead and do a different color. Green, I guess. So let's just say that negative 10, 10 is kind of over here, where for some reason I just deleted stuff instead of drawing it. Okay, so I'm just going to say that that's negative 10, 10 right there. That's my initial condition. So I would start at the point negative 10, 10, and all I want to do is follow the arrows, and that's going to draw out the solution for me. So the arrows kind of tell me to do that. Not a great picture, but we have the general idea that it starts out really steep going down, and then it's going to level out when it crosses the y-axis where we have that zero slope, and then it's going to start to become steep but positive. And so if we were able to solve this initial value problem, we would get some y of x equal to a function that gives us this shape when we try to plot it. And I guess I will just indicate that is shown by a star. And then we could do this for another initial value problem. So suppose we had the same differential equation, but this time we had to start at y of negative 10 is equal to minus 10. So now my x0, y0 is going to be minus 10, minus 10 instead of minus 10, 10. And I will start that at like a circle shape. So I already had, oh no, wrong color. I already had minus 10x written, but I didn't have minus 10y, so let's just say it's there. And so I would want to start at this point right here. I don't know why I keep doing that. Minus 10, 10. And I'm just going to follow the arrows. So they start out kind of steep. They start to level off. They become flat. They start to become negative and then more steep. And that would be the solution to this second initial value problem. I guess I shaded that in on the picture. Okay, apparently scribbling means erasing on my tablet. I gotta be careful about that. And so these curves are just representations of solutions to these initial value problems. And later in class, we'll learn how to actually find those solutions, and then you could graph them without this tool, but just for now, this is how we would find them. I do want to mention that in practice, we are going to be using computers to generate our direction fields. So this, this first thing we did where we drew all the arrows out was very tedious. And so it's better if a computer does it, and then we can just use the direction field. So the thing that I really want you to be taking away from this is what the direction field tells us and what it's good for, or what we can learn. And what we're learning is what the solution looks like. So that is the first and last time, I think, that we will carefully draw a direction field. And next up, what we're going to do is a software demonstration of how you're actually going to generate the direction field on a computer.